Hello and welcome to this video where we're going to be looking at similar triangles. In mathematics, the word similar means that the shapes themselves are not identical but are the same up to a scale factor enlargement. So one of the shapes is an enlargement of the other. So it could be a scale factor 2 where all of the lengths are doubled. It could be a scale factor 3 where all the lengths are tripled. It could be a scale factor half where the lengths are halved. But in some way, all of the corresponding lengths on these triangles are in an enlargement. So what we do to find the missing side in a similar triangles problem is we identify the corresponding sides. So this x here corresponds with that 10. So the scale factor for those sides we would write down as a fraction x over 10. Now if we divide x by 10, we should get the same scale factor as if we divided 16 by 20 because they are also corresponding sides. They're both the base of those triangles. So we'd write 16 over 20. Now a common mistake here is to possibly write that 16 and 20 the wrong way around, so people might put 20 on the top and 16 on the bottom. You must remember that if you started with the smaller one of the triangles on the top, you must do the second fraction in exactly the same way with the smaller triangle on the top. So x comes from my small triangle, 16 comes from my small triangle, the 10 and the 20 both come from my larger triangle. Now this must be the case, and then from here it's a simple one-step equation to solve. So if we multiply both sides by 10, then on the right hand side we get a times 10 has appeared. On the left hand side the divide 10 here has cancelled out, so we get x equals 16 times 10, well that's 160, divide that by 20, and then that comes out as 8 centimetres. At this point it's a good idea just to look back at your triangles and see if that makes sense. So this here being 8 centimetres, well the 16 is smaller than the 20, so we'd expect the 8 to be smaller than the 10. If you possibly get this fraction upside down and do it wrong, you'll end up with this length being bigger, so that's a good way to check if you've made the right approach. Let's have a look at a second example then. So again, the first thing we do is we find the corresponding sides in these triangles. So I'm going to match up this x with this base here and write that as x over 5. I'm then going to do the same thing, and I've got 6 matched with 4, but I've got to make sure this fraction is the right way up. So this time I started with the larger triangle x, so I'm going to start with the 6 on top of my fraction, and then the 4 underneath, and then I multiply both sides by 5, so 6 times 5 over 4, and the 5's cancelled out on the left. 6 times 5 is 30 over 4, and 30 over 4 is 7.5 centimetres. So the actual solving bit of this is very straightforward. The only place you can really go wrong is by setting it up wrong in the first place. Okay, here are two questions quite similar to those for you to have a go at. Press pause, try these yourselves, and then when you want the answers press play and I'll tell you what they were. Okay, the answers to these then, we've got x over 15 equals 8 over 20. We multiply by 15 on both sides, we get x equals 8 multiplied by 15 over 20. And this comes out as 120 over 20, and therefore x equals 6 centimetres. This next one here, we've got x over 6 equals 15 over 10, making sure that we get this fraction the right way around. So x equals 6 times 15 over 10, so x equals 90 over 10, in which case x equals 9 centimetres. Okay, another similar triangles problem here then. This one's not as obvious that it's a similar triangles problem. In fact, we're not told that in the question this time. We're simply told that BD and CE are parallel. So this line here is parallel to this line here. Now a consequence of that is when you see a diagram like this and these two are parallel, the triangle ABD and triangles ACE are similar. It's not as obvious how to do this question when the diagrams combined like this, so what I like to do is separate them out into the two triangles. So I've got the triangle, so you can sketch these out, A, B and D, and the lengths of that triangle are 3 on the height and x for the base, and my larger triangle is going to be A at the top, C and E. So this is the whole triangle here. Now the base is 15, but a common mistake here is to write the height as 6 because you think you've used the 3, so the height of this one must be 6, but the height of the whole triangle is actually 3 add 6. this 3, and this 6 here, so the height is 9. And now we just solve this like we did the previous questions, using the scale factors for the corresponding side. So I'm going to start with x here and 15, so I have x over 15 equals, and then 3 over 9, this one and this one, making sure that I have the smaller triangle lengths on the top. So x equals 3 multiplied by 15 over 9, and therefore x equals 45 over 9, and then x equals 5 centimeters. And that's that problem solved. So the only difference with this to the previous ones is that the triangles are actually combined in this larger diagram, and it's much easier to separate them out into these two diagrams in order to continue. Here's a second example of one of these combined diagrams. So again, I'm going to try and separate it out into the two triangles that I can see. I've got triangle A, B, D at the top here, which has this length is 4 centimeters and a base of 3 centimeters. I've also got the larger triangle, this one here, which goes C. I've got A at the top and E at the bottom, and I've got a base of 10 centimeters, but the height here, or the sloped height I should say, isn't x, it's in fact x add 4, because I've got this whole length here from A to E, so it's x plus 4. So in exactly the same way, and I'm going to start with the bigger triangle because that's got an x in it. I'm going to have x add 4 over 4, so these two are corresponding, and that's going to equal the larger triangle 10 over 3. And this is slightly more difficult to solve. I would start with timesing both sides by 4, so you get x plus 4 equals 40 over 3. Then times both sides by 3, remembering that you would multiply 3 by the x and the 4, so as though it was in a bracket. 3 lots of x plus 4 is 3x plus 12. So a common wrong answer here is that 12 ends up as a 4 still, equals 40, and then 3x equals 40, take 12, that's 28, in which case x equals 28 over 3. Now that's not a nice integer, so I'm just going to leave it like that, and that's my answer to this question. Okay, here are two of these more complicated ones for you to try. Press pause, have a go at those, and then press play again and I'll tell you what the answers were. Okay, so the answers to these then, we have for x over 15 equals, so that was the larger length over the smaller length. I've got the larger length here, which is actually 10 add 5, so 15 over the smaller length, which is 5, in which case I end up with x equals 15 times 15 over 5, and that gives me an answer of x equals 45 centimeters. This next one here, I've got x for the smaller one here and x plus 8 for the larger one, remembering that I need to add this x and the 8 together, and that equals 5 over 15. Now this one here, I'm going to multiply both sides by 15 first, so I'm going to get 15x equals 5, and I've still got over x plus 8. Then I'm going to multiply both sides by x plus 8, so I end up with 15x equals, and I've got to remember the 5 multiplies all of the x plus 8, not just 5x, the 5 are multiplied by the 8, so I'm going to write that in a bracket. So 15x equals 5x plus 5 8s are 40, take 5x from both sides, 10x equals 40, and then divide by 10, x equals 4 centimeters.